Hey all, welcome back to another video on the Hacking Windows Domain Active Directory series. This is the second episode of the series, so if you have yet to watch episode 1, please check out episode 1 first. The link to the video will be in the video's description. Episode 1 will provide the introduction on the setup and configuration, and it will provide more context. It is highly recommended to finish watching episode 1 first before you continue here. With that being said, let's get started. In episode 1, we covered the following attack path shown here in BloodHound. Basically, our initial access via Steven Lim has a beautiful attack path that we can take in order to obtain domain admin privileges. So, what if that was not the case? What if our initial access via Steven Lim has no viable attack path to reach domain admin? With a valid domain user account, such as Steven Lim, there are many other ways we can look at if there is no attack path available from the initial foothold, such as using Steven Lim. One such method is known as Kerberoasting, which on a high level refers to requesting an encrypted service ticket and attempting to crack it offline. It doesn't always work because it ultimately depends if the password is crackable or not. Sometimes the service account that has the service principal name SPN set will be configured with a strong and secure password, hence it might not be possible to crack the password. With that in mind, let's proceed with Kerberoasting. You can only request a service ticket with Kerberoast if you have a valid domain account. In this case, we do have the Steven Lim domain user account credentials. Let's get started. Let's run SharpHound again with Steven Lim and port it into BloodHound on our Kali machine. After executing the SharpHound PowerShell script to collect the AD data, we should have a compressed file as output. Now, we can upload the data onto BloodHound. Looking at BloodHound, we can see that our initial foothold via Steven Lim has no attack path available. The reachable high-value targets field value is 0, which is different from what we had in episode 1. Looking at the local admin rights, we can see that Steven Lim has no administrator access onto any Windows machine at all. We can check out the Analysis tab whereby a pre-built query that will display all users that we can perform Kerberoast attack on. Clicking on it, we will be shown with two users. The first user, KRBTGT service account, can be ignored. This is created for the Kerberoast service and the password is basically uncrackable. We can see that there is another user account, Roy Kingston, that has the service principal name SPN set. This means that we should be able to execute a Kerberoast attack on the Roy Kingston user. Although Roy Kingston has no reachable high-value targets as well, we can see that he has local administrator privileges on the Windows 10 workstation. With administrator privileges, we will be able to dump credentials on the Windows 10 computer and potentially harvest more credentials to use as a starting node here in BloodHound. With that being said, let's get started with the Kerberoast attack. Let's hop over to our Kali machine. One way we can request for the encrypted password hash of the target user is via the GetUserSPN Python script from Mimikatz. We can request for the encrypted ticket remotely. This means that we can execute this on our Kali machine itself without having to be domain joined. We will need to specify the necessary flags as shown here. This will output the encrypted ticket file that we can perform the offline cracking into the file named #roykingston.txt. Oh no, we totally forgot that the DC 10.10.10.10 is unreachable as our Kali is in a different subnet. Let's set up network pivoting first. We will quickly do that. We have went through this setup with explanation on the first episode, so this will just be a quick run through. Let's establish a shell session first with Metasploit and Metabreeder. Alright, this looks good. Let's fire up auto route. Awesome, the 10.subnet has been added successfully. Next, we will be executing the SOCKS proxy. This will allow external tooling to proxy chains over the Windows 10 machine and reach the 10.x subnet. Let's verify that the proxy chains configuration file is pointing to the right SOCKS proxy IP and port. Okay, great. Now let's verify that external tooling such as CrackMapExec CME can now reach the DC IP in the 10.x subnet with proxy chains. Awesome, let's fire up the same GetUserSPN command now. We can append proxy chains at the front of the command. Great, it works now. We can reach the LDAP port on the DC 10.10.10.10. We now have the encrypted NTLM hash ticket in the file as shown. Now let's crack it. There are many tools available to crack the encrypted ticket file such as John the Ripper, Hashcat, and even the TGS crack Python script. Let's go with John the Ripper for this episode. We will need to specify the correct format and a word list to use. Let's use the infamous ROCU text file available on our Kali machine. Nice. It was able to crack almost instantly, revealing the password to be a mutated version of password. Let's verify the admin access on the Windows 10 machine. We can do so using CME. As shown over here, the PON indicates that Roy Kingston account indeed has admin access on the Windows 10 workstation. Awesome. Let's get a privileged session on our Metasploit console with PSExec using Roy's credentials. Okay, looking good. Now we have two sessions. The first session is our low privilege Steven Lim session, and the second session is the privileged system session. The next thing we can do in order to move forward is to dump credentials. Let's dump the local SAM registry to harvest the credentials of the local Windows account on this Windows 10 machine. A very common configuration in the Windows domain AD environment is the usage of the same local admin password across the Windows domain computers. Let's try that out. We can quickly do a password spray attack with the local administrator NTLM hash across all the Windows domain computers to verify if any of it is using the same local admin password. Let's create a target.txt file first. The first IP address will be our Windows 10 machine, followed by the two other Windows Server IP addresses, the dev server on 10.12 and the DC on 10.10. Now, let's fire up CME again. Instead of specifying an IP address as the target, we can simply use the target text file. As shown in the screen, we were able to quickly verify that the local administrator account password works on the Windows Dev Server endpoint on .12 as well. This means that the Windows 10 workstation and the Windows Server 2019 Dev Server are sharing the same local administrator password. It is a pity that the DC has a different local admin password. Now let's look at the Windows 2019 Dev Server endpoint on BloodHound. We can see that from the Dev Server as the starting point, it has reachable high-value targets. This means that we should be able to priv-as ourselves to domain admin now, since we have administrator access on the Windows Dev Server. This is because on the Windows Dev Server, Kevin.rich has a session on it. If we have admin access on the Windows Dev Server, we can proceed to dump the credentials of the server and obtain Kevin.rich's credentials. Now, we should be able to gain a remote administrator shell access with PSExec on the dev server, since we have the admin credentials. Let's do that. Let's set the necessary options for PSExec to execute on the .12 Windows Dev Server. We will need to set the SMB domain to be a single dot, as this is a local account, not a domain account. Great, it worked as expected. We now have a session on the Windows Dev Server on 10.12. Let's fire up Mimikatz on the Metapreter session with the Kiwi module. Alright, looking at the password dump, we should be able to identify Kevin's credentials here. Nice, we got it. The final step now is to get a shell on the DC, 10.10.10.10 with Kevin's credentials. We can do so using PSExec again. Awesome, this is it. We now have compromised the entire Gemini.local domain. In this video, we have demonstrated how we can identify vulnerable users that we can perform the Kerberos attack on, as well as how to perform password spraying with the local administrator account hash that we have obtained against all of the Windows computer in the domain. So this is it for this episode in the series of Hacking Windows Domain AD. I hope you all have enjoyed the content. Feel free to suggest any techniques, tactics, or tools that you would like to see being covered in the upcoming videos. Also, please help to like the video and subscribe to the channel. It will really help out the channel a lot. Thanks all, and I will see you soon in the next video. Bye.